Hello, children. How are you all? And we are again back into learning about the structure of atom. So we were talking about the models of atom put forth by a few of the scientists, and they're not being accepted. Also, we have seen what were the two models that were discussed previously. So there was the first model of atom proposed by J.J. Thomson, and what are the pros and cons of this model? Pros are it talked about the neutrality of the atom, but it failed to talk about the stability of the atom. So it failed to account for the stability of the atom. That is, why are atoms still existing or stable, though the positive and negative charges are together in the mass of the atom? So that was a failure of Thomson's model. And later on, his student Rutherford, he conducted the famous alpha particle scattering experiment on the gold foil, and he put forth the model of atom. And there he said that the atom is almost hollow, and the whole of the negative charge, all of the positive charge was concentrated in a very small space called as the nucleus. Okay, nucleus is positively charged. That's very fine. And next, he also said that the electrons are revolving around the nucleus like planets around the sun. So we call it as a planetary model of atom. And Thomson's model was called as watermelon model or plum pudding model. That's okay, the names. The next one. Now, there is a classical law of physics that any body or object which is revolving around in a circular path should gradually gain acceleration and finally fall into the nucleus of finally fall towards the center. So here, the electrons being negatively charged and also revolving around the nucleus, which is positive, it should also gradually lose energy and gradually finally fall into the nucleus. So, children, so again, the negative electrons and the positive charge of the nucleus, they should again come together according to this, and finally, the atom should collapse. Again, there is a compromising aspect with what is called as the stability of the atom. So, atoms should not exist according to Thomson's model and Rutherford's model, but we see that atoms are continuing to exist. So what do we understand from this? So that these two theories or atomic models, they are not right in some important case of stability of the atom. To understand or to explain the stability of the atom, another student of J.J. Thomson, he came forward and gave a very good model which is even accepted now with small variations by subsequent scientists. So what is this that we are studying about? We are talking now about structure of the atom, structure of the atom, and proposed by Niels Bohr or Niels Bohr's model of a atom. So what is this Bohr's model of atom? What is this Bohr's model of atom? What is it saying? Now, according to Bohr, he said that yes, atoms they are there, and in the atom there is a nucleus. Okay, right, that was told by Rutherford. But the electrons are revolving in the orbits. That's also right. But how are these orbits? That is special about Bohr's model. He introduced something special about these orbits that are having the electrons. All the electrons are revolving them. What are they? So he said that there are separate energy levels or discrete energy levels, also called as stationary states, and in these the electrons, when they are revolving, they will neither lose energy nor gain energy. So children, so they will never lose or never gain energy by themselves. So that's why he called them as stationary states or discrete levels. Okay, children, right. So this is first aspect about the first aspect about Bohr's model of atom. So, children, right, we are having the Bohr's model postulates. We write the postulates of Bohr's model. Right, the postulates are electrons revolve. Electrons revolve in certain specific orbits around the nucleus. Around the nucleus in certain specific orbits called as discrete orbits. Okay, what is special about these orbits? The special thing about these orbits is as long as these electrons are revolving in them, they can neither lose nor gain energy by themselves. So these are the two parts of two postulates of what are called as the model of atom proposed by J.J. Thomson. Right, okay. Now, what more do we find about this model? So, children, there are a few more aspects that you can learn and understand that's better for you, and they are as follows. Now, so these electrons sometimes they gain energy from outside by themselves. They cannot have more or less energy. They cannot lose or gain energy. But one thing is there, that is these electrons, if they are given some energy like heat energy or light energy from outside, they can gain energy, and they jump from lower energy to higher energy orbits. Right, look at children. Now, what are lower energy orbits and what are the higher energy orbits? We will try to depict them in a diagram and understand. So, children, if there is a nucleus and there is one level and an electron is there, there is the second level and the third level. Like that, we have different levels of the atom or orbits of the atom. And say there is one electron here in this level. Now the levels are named and the levels are named by alphabets K, then L, M, and the next we have the shell N. Like that, they are named, and they are also given a number n equal to 1, and that is n equal to 2, n equal to 3, and n equal to 4. So if at all, so each of these levels is either given a name or given a number, which is later on called by Bohr as the principal quantum number, which you'll be learning in the later classes. Right, now follow carefully, children. So these are the shells or the stationary orbits in which the electrons will never lose or gain energy. But when some energy is given to the electron in the lower energy orbit. So what is lower energy orbit? The orbit which is closer to the nucleus is said to be lower energy orbit, and the orbit which is having which is just above and away is the higher energy. As we go away from the nucleus, the size of the orbit or the radius of the orbit and the energy of the orbits will keep on increasing. So children, this is how it is happening inside the atom. Now, when energy is given to this inner electron or the lower energy orbital electron, say if the energy is E1 for the orbit, so when it takes certain amount of energy which is equal to h times nu, you learn this is called as a Planck's constant, and nu is the frequency of the radiation or the energy that is coming in. So what will happen, children? So this will jump to the higher energy orbit, and when it jumps to higher energy orbit, what happens is the electrons will have more energy, and that becomes what is called the excited level or state for the particular electron. So electron absorbs energy from outside, jumps to the higher energy level, but in this level the electron which has jumped is said to be unstable, and it will gradually lose its energy and come to what is called the original level, which is called as the ground ground state. Okay, ground state. Now what will happen here? So when electron jumps down, again it will release the same amount of energy that it has absorbed. So children, we find that electrons by themselves, according to Bohr, they can never gain or lose energy. But one thing is there, that is the electrons, when given energy from outside, they can absorb energy and jump to higher energy levels. But at the higher energy level state, they are unstable. They radiate energy or give away energy in the form of some visible radiation of certain frequency, say nu again, and they will come back and fall to their ground states or the original states to which they belong. So, children, this is a Bohr's model of atom. So, children, now we talk about now there are a few more aspects about Bohr's model, children. They are worth knowing. What is that? As we have seen, that there is jumping of electrons and jumping back of the electrons. In order to jump up, they need energy, and to jump down, they release energy. That's good. So this is one aspect of Bohr's model, which is worth learning as you get into the higher classes. Will be useful to you. The next one we have another model of the another part of this model, that is everything that is going in a circular path will usually have what is called as angular momentum. So they will have angular momentum, which is a physical quantity attached to the circular motion of any particle. So this angular momentum is usually denoted by the angular momentum and that will be equal to that will be given by mvr, where m is the mass of the electron, v is the velocity of the electron, and r is the radius of the path, and that will be equal to nh by 2 pi. So this is one aspect that Bohr also told in his model. So n is the number of the shell, h is called the Planck's constant, it has certain value, h is equal to 6.625 into 10 power minus 31 joule second. So children, that is right. Okay. So children, this is the value of Planck's constant. This is called Planck's constant. Such value, and h by 2 pi. 2 pi is a constant. Okay, good. So this is also another aspect of Bohr's model of atom. Right. Next, what else do we find in this? So children, right, this is it. And Bohr's model of atom, it gave an idea about what is called the spectra or the spectrum of spectrum when atoms they get excited. That is, electrons, they jump to higher energy levels, and they jump back to lower energy levels during while jumping up, they give what is called as absorption spectrum or line absorption spectrum, and jumping out down to lower energy levels, they give the released or emission spectrum. And these spectra are nothing but lines of light of certain frequencies. Oh, they are not continuous bands like that in a rainbow, but they are like streaks or lines as the jumps are happening in the levels of between the levels of the atom. So children, this is the Bohr's model of atom. Now, okay, right, what did it explain that Rutherford's model could not explain? Yes, it explains something very important, and that is atoms, the nucleus is there, okay, and the electrons are revolving, that's also okay, but how are they not falling into the nucleus? That's the idea which Bohr's model explained. What is that, children? The electrons, they are revolving around the nucleus, but they're not falling into the nucleus because those are specific orbits where there is a special property for the electrons as long as they are revolving around the nucleus, and that is the ability not to lose or gain energy. Such when these are called stationary states or discrete states. Okay, right. Apart from that, we have seen other aspects of Bohr's model of atom. They jump up when they are given energy from outside, and they jump down under other conditions and release energy. And the next, there is certain aspect called as angular momentum associated with the electrons as they are revolving around in an orbit, and that causes what is called angular momentum, and that is equal to nh by 2 pi, where h is Planck's constant, and that's the value of the Planck's constant, right? Okay, children, there we are. And now next, so children, right now we have seen the various postulates of Bohr's model. Now, is it all right now? So, do we know the whole picture of the atom? Is it all correct? So that's the idea. Now, next one. So if we check, the subsequent scientists have found some flaws even in Bohr's model. Now, what are they? So, children, I have listed out the different drawbacks of Bohr's model found out by the subsequent scientists. What are they? So let us look into them. Right. Okay. Now, drawbacks of Bohr's model of atom. So, what are they? Now, Bohr's model of atom was not able to explain the arrangement of electrons in the orbits. How electrons are arranged in the different orbits of the atom, that was not explained by Bohr. So he said electrons are revolving around, they are revolving around and not losing energy by themselves or gaining energy by themselves, but it did not tell how electrons are arranged. So whether there is a limit to a certain number of electrons in each orbit, or that. The next one, not able to explain the spectrum of the system or atoms having more than one electron. So what is spectrum? So children, when electrons are jumping down or going up, light is either released or absorbed by them, as we have learnt. But how is this light coming out? This light, when passed through a spectrometer, we find a device called spectrometer. We find separate lines. It's not a continuous spectrum like that which is seen in a rainbow, but it is different lighter lines or color lines um, uh, in the spectrometer. So this is called the line spectrum, and that line spectrum he was able to explain for a single electron system like a hydrogen atom which has one electron, or a helium atom which has lost one electron, so it will have one electron only in it, and lithium which has three electrons in it. If it loses two electrons, it will again become a single electron system. It's a lithium ion, lithium 2 plus ion we can call. So this system, the spectrum, was not explained by Bohr. So that's it. And children, on closer examination of the spectral lines, it was found under spectrometer that there are finer lines. So this is called the finer spectrum, and this also was not explained by Bohr. Okay, right now later on, children could not explain splitting of spectral lines. So children, on a gas which is emitting this light, when electric field is applied, the lines of spectrum will split, and that is called a Stark effect. And when magnetic field was placed, that would also split the spectral lines. That is called as a Zeeman effect. So not able to explain, could not explain the Zeeman effect or Stark effect. Later on, could not explain the chemical bonding. So children, when substances combine, the atoms they combine to form what are called as compound atoms or molecules. Right, these molecules which are formed, they will have a permanent force of attraction, which is called as the chemical bond. This chemical bond formation, how this is formed, that was not explained by Bohr. So the children, we have learned about the defects or the drawbacks of a Bohr's model, which were dealt and easily explained by the subsequent scientists who have done a greater research to get into the details and give a clear model of atom. Now children, to what extent have we learned till now the three structures of matter that we have seen? Thomson's model, okay, then Rutherford's model, and now we have the Bohr's model. Now, do we know the whole structure of the atom? Let us see what we have learned. So, children, now we have our this is the structure after Bohr's model of atom. After Bohr's model, this was the structure that we have understood. Now we know this. The scientist community knew about this model of atom after Bohr's ideas. Right? What is that? So there's a nucleus in the center that's positively charged, fine, and electrons are revolving in certain specific orbits called the stationary states. Okay, good, or discrete orbits. Now these are electrons. Now, okay, right, electrons were discovered by electrons were discovered by, we know that J.J. Thomson. And what is the charge of these children? The charge of it is -1 unit, and the mass is a negligible mass. So it is very, very insignificant mass in the total atom's mass considered. Now next one, we have the proton. Who found this proton, children? It was a Goldstein that we discussed in the previous parts. And what is the charge? It was +1 unit, and they are equal and opposite charges, both electron and proton. And the next we have the unit of mass. The mass is 1 unit of mass of proton. And the next one, neutron. Now this is something special, right? Okay, there is in the subsequent findings, there was a discrepancy in the masses of the atoms and the number of protons. So this gave an idea to one of the scientists by name Chadwick that there may be some other particles which could add to the mass which is more than the number of protons, and that he found that there are certain other particles in the nucleus of atom which are called as neutrons, and these are neutral particles. They are not having any charge, so still the charge on the nucleus is positive, and result again, the mass is almost equal to that of a proton. So this was discovered by Chadwick. Okay, children, right. So, children, this is about the structure of atom known to the scientist community after Bohr's model. So, children, thus we have learned about the various models of atom till now. So, the Thomson's model, then the then the Rutherford's model, the Bohr's model, and now we have the Bohr's postulates, telling that electrons can revolve around the nucleus, but cannot radiate energy by themselves or lose energy by themselves or otherwise gain by themselves some energy. But in we give energy to those electrons, they will gain energy and jump to higher energy orbitals, but they will be unstable and they will radiate that energy and come and fall to the lower energy levels or the ground levels, and resulting in radiation coming out, and that radiation is visible as visible light and of a known spectrum is given from that, and Bohr was not able to explain the spectrum of systems which was which was having more than one electron. Later on, the other scientists could explain, and a few other facts like Zeeman effect, Stark effect also were not able. He was not able to explain. So, children, that's it, children. This is how we have concluded the Bohr's model of atom, and the subsequent scientist by name Chadwick, he was able to get an idea that there are particles called as neutrons in the atom, in the nucleus of the atom, which were almost similar to proton in the mass, but they are neutral. And this is how they have found a new structure of atom with three particles, electrons, protons, neutrons, which are called the fundamental particles of the atom, because they make up the charge as well as the mass of the atom. There are a few more particles inside, children, which you will not be learning now, but as you go into higher classes, you will be learning it. So, children, that's it, children, now for now, and thank you very much.